Welcome. We're going to start chapter 5 and we're actually going to do the first two sections together. The reason for this is because the first two sections have several different things that work together. Specifically, we're going to talk about rules of exponents for 5.1. 5.2 is negative exponents in scientific notation. But negative exponents make much more sense when we talk about them in the idea of what are the rules of exponents. So we're going to combine them into one lecture. Now, as we go through this, let's talk about exponent rules. So before I get into exponent rules, let me explain something. I'm going to show you why each exponent rule works. I'm not just going to tell you it and memorize it. If you want to do that, you can, but that's the ineffective way to actually use this. The more you understand about why exponents work together the way they do, the more likely you are to use them appropriately. If you're just trying to memorize some blind rules, then that's going to have some struggles. So to get you started, I want you to just explain to me, what does 2 to the 5th power mean? So pause and take a moment to write down, what does 2 to the 5th power mean? Welcome back. Remember that something to an exponent means I'm going to take that bottom number 2 and I'm going to multiply together whatever the exponent is. So I'm going to multiply it together 3 times like this. So 2 to the 5th power is this. This is the basic idea that we're going to use to understand everything else that we're going to do. So let's go on to what's called the product rule. This is the basic exponent rule out there. Now, as we're doing this rule, here's an example. So what if I have x to the 3rd times x to the 5th? And that in the middle is a multiplication symbol. I'm doing this because sometimes you guys like to use those multiplication symbols. I recommend dots in this case rather than the multiplication symbol, but I want to make it clear. If you do that, here's some dots. Notice x to the 3rd, I can break it up into these 3 parts. X to the 5th, I can break into these 5 parts. Okay, notice I have a bunch of x's times a bunch of x's. So how many x's am I multiplying together? Hopefully you said 8. Well, notice, what is 3 plus 5? It's 8, which leads us to what the rule is. The rule is if I have x or anything to a power times the same thing to a different power, or just to any other power. In fact, they could be both the same powers. All I'm going to do is I'm going to add the exponents. So if it's multiplication of the same bases, you add exponents. Let's move on to the next one, which is called the quotient rule. Well, quotients are the opposite products. So you can kind of anticipate how this is going to go, but to show you how it works, suppose I took x to the 7th and divide that by x squared. Because fractions are just a division problem. All right, I want you to pause and say, what is x to the 7th and what is x squared? Well, notice if you break it out all the way out, write it as all the times, it's x 7 times. But notice this x, these last 2 x's would cancel. It doesn't really matter which 2 x's on the top. But 2 of the x's would cancel with the 2 on the bottom. And if that's the case, how many x's would be left on top? Hopefully you're saying 5, because if I cover up those last 2, which is kind of hard in this little cursor thing, then I end up with just x to the 5th power. So remember, if I had products where I multiplied things, if you're multiplying, then we added the exponents. So if we're dividing, which is the opposite of multiplying, what's the opposite of adding? You're thinking subtracting. So the rule is if I'm dividing two things that have the same base, that's really critical, by the way. This thing is called the base, and this is the exponent. If the bases are not the same, these rules don't work. So they have to have the same base. Then I get to go ahead and subtract the exponents. All right, let's move on to something that's related to the quotient rule. It's kind of important. It's called the 0 power rule. So I'm going to take some number, x, to the 0 power. And I want to know what that means. So do this. I just did something here where I said 5 minus 5 is equal to 0. Hopefully all of you agree that 5 minus 5 is equal to 0. Well, based on the quotient rule we just did, this, when we take a minute and think, how could I write this as a division problem? Well, you can write it as x to the fifth over x to the fifth. Because remember, any equal sign means I can go backwards. So if you take the last quotient rule, which means if I have subtraction, I take the first number, that's going to go for the exponent of the top, divided by the second number is the exponent below, the thing that's being subtracted. But what is any number, x to the fifth, divided by x to the fifth? Hopefully you're saying 1, which in fact that's true. So the rule is x to the 0 power is equal to 1, with one little caveat, and that is that x cannot be equal to 0. So this is true as long as x is not 0. Otherwise, this is true for everything else. Well, another important thing, this goes into 5.2, are negative exponents. What does a negative exponent mean? Well, let's just look at an example. X to the negative 3. So my exponent now has a negative sign in it. First and foremost, do not misunderstand that negative exponents do not mean negative numbers. And negative numbers do not mean negative exponents. They're very different. Both negative, but exponent versus a negative number, very different. To understand this, again, I'm going to use the quotient rule. And I'm going to use, what does negative 3 really mean? Hopefully, if you think about it, it means 0 minus 3. Again, if I have x 0 minus 3, how can I write that as a division problem using the exponent rules, specifically the quotient rule? Hopefully you're saying that's x to the 0 over x to the third, but x to the 0, like we just did, is 1 over x to the third. So notice my negative exponent turned to a positive exponent when it moved below. And so the rule is if I have anything to a negative exponent, I can move that down to the bottom and write it as 1 over x to the positive version of that same thing. So this is what negative exponents are, and this will help you be more successful in understanding this. So now let's move back into some other general exponent rules. The power rule. What is the power rule? Well, the power rule means, suppose that I have something to an exponent, and then I'm raising all of that to another exponent. What's this mean? Well, what's it mean to square x cubed? Let's just go back to the basics. X squared, does that mean that I have x cubed times x cubed? Wait a second, can I now apply the product rule we had before? Okay, what's the product rule say that I do with those exponents? Hopefully you're saying I add them, and 3 plus 3 is going to give you x to the 6th power. But wait a second. What if this had been instead of a 2 out here, instead of squaring x cubed, what if I did x to the 4th power? Then if I had x cubed times x cubed times x cubed times x cubed. Could we add them up? What do you do if you add the same number together a certain amount of times? What are you really doing? You should have learned way back when you were a little child that that is what multiplication is. Multiplication is just adding the same number together a whole bunch of times. So what we're going to do here is if I have something inside the parentheses and an exponent outside, these two exponents are actually going to multiply. So we multiply exponents whenever we have something to an exponent and we raise it to another exponent. So that is how we're going to get this. Well, what about what happens if I have two things inside my parentheses? So we knew how to do it before. Let's use the same idea. Can I rewrite this as, just write it out. What does it mean to square something? I have x squared y cubed times x squared y cubed. But a basic rule of algebra is that I can multiply anything in any order that I want. So in this case, I have 4 things being multiplied. So I am just going to take a moment and I'm going to rewrite, I'm going to take the x's and move them over. So multiply the 2 x's together and the 2 y's together. Notice, what is x squared times x squared? Hopefully you're saying that's x to the 4th because 2 times 2 is 4. 3 times 2, because I have 2 3's, 3 times 2 is 6. So if you put that all together, you get x to the fourth, y to the sixth. Well, the rule kind of looks like this. If I have any values on the inside, and I'm raising to a power, each of the individual things inside is going to get raised to that same exact power. So this is going to apply back to the previous rule, the power rule. We're going to put that together. So what about fractions? So what if I have this to a fraction? Well, this actually is just like the power rule. So we can think about it in this way. Let's go back again. Well, x cubed means I have x over 3 times x over 3 times x over 3 because I'm multiplying together 3 times. How do you multiply fractions? Hopefully you're saying straight across. So if I do that, I have x is just the x's being multiplied together, which is x cubed. Or in other words, I just multiplied that together 3 times, and this together 3 times, which is 3 cubed, which is 27. So the rule is we distribute to both the numerator and the denominator, so each of them will get the rule. So let me do some examples. I want to multiply these two together. So let me ask you a question. Which rule am I going to use? Hopefully, you said use the product rule. So if not, go back with the product rule. Think about it for a second. Come back. So using the product rule, remember if we're multiplying, what do we do with the exponents? We add them. So it's a to the 7 plus 5. Well, 7 plus 5 is 12. And that's it. That's all you had to do. All right, so let me give you another example. Can you do this one? Again, ask yourself, which rule am I doing? And then try to apply that rule. All right, so hopefully you work through it. The rule we're using, because we're multiplying things, is we're using the product rule, because product means multiply. So there's a critical thing to remember here, and that is that x really means x to the first power. Even though you can't see that 1, that's just because we're lazy and we don't write it. It's also why 1 is the loneliest number in the world. So in this case, if I do this, if you left that 1 off, then stop it, come back and add that 1 in. Now can you keep going forward? Hopefully you said, well, again, we add them, and we get x to the 12th power. It's just coincidental, by the way, they both have the same exponent in the end. I just happened to pick numbers that worked out that way. So let's move on to the third example. Notice I'm still multiplying things. So how do we multiply these? Which rule are we going to use? Hopefully you said we're going to again use the product rule. All right, pause the video and make sure you try to multiply this out. All right, so hopefully you did it. The first thing we can do is actually we can rewrite the order of multiplication. Again, I have 4 things being multiplied together, so I can multiply in any order. So I notice I multiplied the 3 and the negative 4 together first, and the y cubed and the y to the 5th power second. These two, we can just multiply them directly. What's 3 times negative 4? And then you can use the product rule on these. So go ahead and do that. Well, hopefully you got negative 12 and then y to 3 plus 5, or in other words, negative 12, y to the 8th power. Okay, let's move on to another example. We've done some multiplication, now division. So if I'm dividing, which rule am I using? Well, hopefully you said the quotient rule. So when you pause the video, use the quotient rule. All right, welcome back. As you did that, you should have realized the quotient rule means I'm going to subtract the exponents. So I have 7 minus 3. 7 minus 3 is 4. Ah, that's pretty nice and straightforward. Okay, well, what if I divide these two fractions? Again, use this fraction or divide these two things. C to the 3rd power and C to the 4th power. Pause the video and work through it. Welcome back. Hopefully you said the quotient rule again. And if you do subtraction, I have 3 minus 4. What's 3 minus 4? Well, it's negative 1. Remember, now it goes back to what is a negative exponent? Well, it's 1 over c to the positive version of the exponent, which in this case is just positive 1. So we can, if you want to include that positive 1, you can, but we normally just drop it because we're all lazy that way. All right, so example number 6. Now we've amped it up just a little bit. I want you to divide both these big giant messes, and then we'll talk about what is that. Okay, so as you work through it, this is still a quotient rule problem. But the key thing here is actually I'm going to break it up. So notice I broke it up into just the numbers, the x's, and the y's. By doing this, it's a little bit easier for you to focus on different things. So first and foremost, what is 12 divided by negative 24? Hopefully you're thinking that's negative 1/2 or 1 over negative 2, however you want to do it. So as we do that, we can do the same thing with the quotient rule for these two. So I have this, I have each of these. What is x? What's 5 minus 3? 2. What's 6 minus 8? It's negative 2. So I should get something that looks like this. But we're not done because we do not like negative exponents. So notice, how can you write x squared as a fraction? Y to the negative 2, where is that y going to end up? Well, x squared really is going to move it to the numerator, and the negative is going to, so the positive exponents are going to go on top. The negative exponents go to the bottom. And negative 2 is not going to mess with anything because it's just a negative number. It's not a negative exponent, it's just a negative number. Okay, so let's move on. Now I'm going to use the terminology simplify. Simplify pretty much means I'm going to want to rewrite this in some form. Often it implies there are several different steps that you're going to use, but it could also mean that there is something how you want to look at this and how it wants to be finally written out. So when you pause the video, can you simplify it? Hint, try using the order of operations. All right. Well, for this thing, the first thing I'm going to do is I'm going to look at the numerator. So if I look at the top, how can you multiply the things in the top together? So you're thinking the quotient rule. So if I multiply them together, I multiply negative 6 and the 3 to get negative 18. X, again, remember this is x to the first power and x to the second power, so I get x to the third power. And y to the fifth and y to the fourth is y to the ninth. And the bottom just gets come along free. Okay, now you have this. If you didn't do that correctly, pause the video and keep going on. So, sorry, click the button by accident. I went ahead and did it. Again, break it up into the numbers, the x's, and the y's. Divide them. Okay, hopefully, again, now notice I'm giving very similar numbers. That's not always going to turn out that way. So don't just try to expect that it's going to turn out. First, these two have in common, I'm going to divide both by 2, and that's how I got to negative 9 over 8. X to the negative 2 and y squared. Well, again, negative exponents are going to go where? Positive exponents are going to go where? Well, negative below, positive above, and boom, we have our final answer. Negative 9y squared over 8x squared. Okay, so now that is actually all about the product rule and quotient rule. It's all we've been using this entire time. Let's switch it up, and now can we do this one? Pause the video, which rule are you going to use, and then go ahead and try it. All right, so hopefully you realize this is a product rule. I mean a power rule situation. Since it's a power rule, what do you do with the exponents? Multiply them. So I have 6 times 4, which is 24. That's it. Okay. What if I have this one? Which rule am I going to use? Hopefully you're saying the power distribution rule. So if not, go back to that rule and just remember, what is that power distribution rule? Okay, so as you work through this, if you distribute, I was very careful. I have 3 cubed, x squared cubed, and y cubed. So remember, this one we'll deal with in a second. But what's going to go on with these exponents for this and this? Just like the power rule we just talked about, this is going to give us x to the 6th power, y to the 9th power, and then 3 cubed, which is 3 times 3 times 3 is 27. There's now a negative exponent, so we go ahead and move on. What about this one? How would you go through this process? Pause the video, work through it. Welcome back. So hopefully you said it is the fractional power of a fraction rule. So we're going to distribute the power to both sides. So x to the 4th over 5 to the 4th. What's and x to the 4th, we can't really simplify that anymore, so that we get that one. What is 5 to the 4th? Well, it's 5 times 5 times 5 times 5. Or in other words, 625. All right, now this is a really big one. I want you to, this will actually employ multiple different ways, and there's different ways to go about it. But I want you to pause the video, and I want you to attempt to do this problem using all the rules that we've gone over. Okay, you have multiple ways. The first way that I recommend those goes back to order of operations. Order of operations says the first thing that you should do is parentheses. So I'm going to focus on what's going on inside the parentheses. So I'm keep that 4, and notice I'm just going to break down x's, y's, z's, and so forth. So what is negative 2 over 4? Hopefully you're thinking that's 1/2. What's this? What's this? And what's this? Pause the video, answer those questions if you didn't already. All right, so hopefully you said this is negative 1/2. This is x squared. What's y to 0? Well, it's 1. Multiplying by 1, I can just make it go away. And then this is going to give me a negative 1. Again, can we shift things around so that we have this as just one fraction, top and a bottom? Well, hopefully you moved it around, so you got negative x squared over 2z. Now we can use that power of a fraction rule to distribute to both. And you can think about, what does this mean? Well, remember the numerator, this is negative 1 to the 4th power, which is just going to give you positive 4. I have x squared to the negative 4, and those two together, we're going to multiply them together to get 8. Z, that's your 1 times 4, let's look at this 4, and 2 to the 4th power is 16. So there we are. So hopefully this is kind of helping you encapsulate how we put all this together. Now let's go back to negative exponents for just a little bit. I want to practice a little bit more with negative exponents. Get an idea down for you. So suppose I have this and I say that I want to write it with positive exponents. So just think, how would you write this with positive exponents? Pause and write something down. Well, hopefully you said all I need to do is I move it to the bottom and make it positive exponents. All right, how do I take this? Now I'm actually going to compute a number, 2 to the negative 2 power. Now be careful, what are we doing with exponents? And does a negative exponent mean a negative number? The answer to that is no. So if we take it, just write it first off with positive exponents. And you get 1 over 2 squared, which is 1 over 4. So notice, take a moment, don't try to do the computation all at one time. Make it over a positive exponent and just apply the positive exponent as we've already done. So all these things are breaking down to small bits. Let's try this one. Write this one with positive exponents. Well, hopefully you realized if I rewrite this, this is just going to be 3 times x to the 4th. And if you're wondering, what? Well, remember, when we had negative exponents before, we moved them down to the bottom. But that means if they're on the bottom, we move them up to the top. Because we could have written of x is 0 on the top, and then we could have just done subtraction. Well, 0 minus negative 4 is positive 4. Hence how we got this. All right, let's do another example that has negative exponents mixed in. So pause this. Now we have negative exponents. Can you use the different rules to rewrite this with positive exponents entirely simplified? Well, first off, we can break it up and look at just the x's. So if we use the quotient rule, it's negative 3 minus 2. And here is negative 4 minus negative 7. I'm being very careful with my parentheses because what is subtracting a negative? Hopefully you're saying that's the same thing as adding 7. So negative 4 plus 7. So that's going to give me negative 5, but then a positive 3. So which of these have negative exponents? Remember, negative exponents go down. They switch. If they're on the top, which in this case they are. If they're over 1, they go down. If they're here, they stay on top. All right, and that's just the final answer. Here's another one. Can you rewrite this with positive exponents? Try to pause the video and work through this problem. All right, so hopefully the first thing you did is we can distribute that exponent. So we get negative 2 to the negative third. And notice when I distribute to the second ones, I just went ahead and multiplied. So I had negative 3 times 5, which is negative 15. Negative 3 times negative 4 is positive 12. Notice a simple negative error and all this stuff will cause issues. Now, before I try doing any calculations, I'm going to rewrite them with positive exponents. Because all the negatives go down, all the positive exponents go up. Now, what is negative 2 to the third power? Well, that's negative 8. So notice I held off on doing the actual computation of the number until I got all the way up to where I had my negative x, until I had gotten rid of the negative exponents and I had positive exponents. You will do much better if that's the case. Also notice, put parentheses around this. Remember, exponents can't reach out to the negative unless there's parentheses around them. So be very careful about that, or else you're likely to drop a negative and get yourself in a bad situation. Just trying to warn you. Okay, here is another example. I want you to go ahead and apply this to positive exponents. Pause the video, use everything we've done, work through it. Welcome back. Again, we can do what's inside the parentheses first. So I get the negative 3, there's nothing else to deal with it. But the x's, I'm going to subtract. So I got negative 5 minus negative 3 and 6 minus negative 6. Well, remember, subtracting negatives is the same thing as adding the positive. So keeping that, it's going to be x to the negative 2, y to the 12th. Now we can distribute this negative 2 to everything. And when we multiply it, it's going to multiply these to make it positive 4. Make this one negative 24. Now negative exponents go where? Below. So move them down. And then negative 3 squared is going to give you a positive 9. X to the 4th and y to the 24th. Okay. So hopefully that makes a little bit more sense and you're feeling okay. I know this is a little bit longer presentation because I just want to kind of hit all the different topics. Scientific notation is the last thing I kind of want to work through. So scientific notation is just a fancy way of doing computations. Specifically, it's for writing very large numbers and very small numbers in a succinct, easy way. So the form always looks like this: ax plus 10n, where a is just some number between 1 and 10. So it can't be smaller than 1, can't even be 10, it has to be bigger than 10. And n is some integer, so it's a whole number. It's not a fraction, it's not a decimal, it's a whole number, but it can be negative, it can be positive. Let's just do an example real quick. So I want to write this as scientific notation. So what I do, first off, let's look at the numbers. So what's the first number that you have if you come from left to right? What's the first digit that's not 0? It's 2. So I'm going to put a decimal right after that. So I have 2.017, and then we can kind of throw away. So we get this part. Now I'm going to have 10 to some power. The question is, so since this is a small number, it's going to be 10 to a negative. And the way we figure that out is I take this and I'm going to move the decimal place how many times? Well, I go once, twice, 3, 4, 5 times. So it's 10 to the negative 5th power. So if the number is smaller than 1, this is going to be a negative exponent. If it's bigger than 1, it's going to be a positive exponent. Use that to your advantage. Here's a big number, 41,500. I want you to pause. Can you write this in scientific notation? So first off, what are the digits? And then 10 to what power? All right, so hopefully you first said the digits are 4.15. Okay, now it's 10. It's because this is a big number, it's going to be a positive exponent. Specifically, it's 1, 2, 3, 4 spots removing the decimal place. So it's 10 to the 4th power. Well, we also can go the other way. So what if I have something like this and I want to write it in decimal form? So again, notice sometimes use this time symbol, sometimes use the multiplication symbol. The dot. It's perfectly fine. Both are multiplication symbols. This, how do you write in decimal form? Well, again, my number is going to have 512, but I'll move the decimal place to the right because it's a positive number, 5 spots. So 1, 2, 3, 4, 5, which means I need 3 more zeros, and you get 512,000, just like that. Let's do another one. What if it's a negative exponent? Now, what is this going to be equal to? I want you to pause the video and write it as a decimal. Well, hopefully you said, and I have to move it 4 spots to the left because it's negative. 1, 2, 3, 4. So I get, and you can just double check. You can think, okay, if I had to write this back in scientific, is it going to give me the same thing? So scientific notation is just a fancy way of writing these same things. Now, really, it's not a big deal because we're dealing with things like 10 to the negative 4th power. This is really dealing with things that's like 10 to the 27th power or 50th power. So really small, really tiny, and I mean tiny. This is where it really comes into play. But it's also useful for doing calculations. So I'm going to do this, and I want to write my final answer in scientific notation. So first and foremost, a division problem means I can actually change it into a fraction. So I can write this first thing on the top and this on the bottom. Now, it's kind of hard with all those dots and all that spacing, but realize the tens are off to one side and these are numbers. If we break this up into the numbers, 3.12 over 8 times 10 to the power. Can you just divide them as is? So what's 3.18 divided by 8? And what is 10 to the negative 25th divided by 10 to the negative 11? Well, hopefully you realize this comes out to be 0.39. This comes out to be 10 to the negative 14th. But this isn't scientific notation because that number is not between 0 and 1. So I'm just going to write this in scientific notation. I'm going to ignore my 10 for a second. This, if I move it 1 spot, so if I wrote this 0.39 as 3.9 times 10 to the negative 1, then this is in scientific notation. But now I have these two things. Well, how do you multiply two things that have the same base? What do you do with the exponents? Again, the power rules, we add them together. So we get this. Now I hope that makes sense. I know this was a long video and I appreciate your patience because there's just a lot of things I wanted to get in here. So please take the time to go over this and make sure you understand how all these different parts work together. If you have questions, please let me know.